We're going to be calculating the mean and standard deviation of a small data set by hand. Now normally, of course, you're going to be doing this using statistical software or a calculator, but it's still a good idea to know where the numbers come from. So let's say I have a small data set of 5 items, and those 5 items are my students and their weekly study hours. Now, if I only have 5 students, and that's a whole population, and I'm going to be using a capital N for the number of items, I'm going to be using the Greek letter mu for the mean or average, I'm going to be using the Greek letter sigma for the standard deviation, and sigma squared for the variance. But let's say that's just a small portion of the students that I have. In that case, that's a sample, and I am going to be using a small n for the number of items. I'll be using an x with a bar over the top of it. It's called an x bar for the mean or average. I'll be using an s for the standard deviation and an s squared for the variance. The easiest way to do this is to make a table and to start populating it. So that's what we're going to do. We'll take a look at the formulas, and we'll also take a look at some visual aids to make things a little more plain. So it looks tough. It's not. So let's get to it. First, we need to calculate the mean or average for the data set. The idea is the same for the population or our sample. We sum or add all of the x values, and then we divide by the number of items. We'll start by entering our x values into the table, and then we will calculate the mean. I'm going to assume that this is a sample, so we'll use the formula for x bar. That symbol that looks sort of like an E is the Greek capital S, or sigma, and it means to sum or add whatever comes after it. So here the sum of the x's is equal to 30. We're going to divide that by the size of the sample, which is 5, and we'll get our mean of 6. The next step is to subtract the mean from each value in the data set and record those values in the table. Note that if you sum them all, they will always add up to 0, which makes a good check to see if you did it correctly. And this is also why you can't use this for calculating the standard deviation. Now we're going to square each of the differences and add them to get the sum of squares. And note that the square of minus x is always positive. That's why we need to use the sum of the squared values to calculate the standard deviation. So here I add them all up, and I end up with a sum of squares of 60. So now we're ready to calculate the standard deviation. Here are the formulas for both population and sample standard deviation. There are several ways to write the formulas for calculating these, and they all give the same results. The first formula in each inset is probably the easiest to understand, and that's what we'll be using. The next step is to divide the sum of squares by either the number of items, n, or the number of items minus 1, depending on whether it's a population or a sample. This gives you the variance, sigma squared or s squared. We don't use this very often for reporting statistics because the units are also squared. For example, it doesn't make a lot of sense to talk about hours squared. So here I'm going to calculate s squared, and I'm going to take my sum of squares, 60, and I'll divide it by n minus 1, or 4, and I'll end up with my variance of 15. Our final step is to take the square root of the variance to get the standard deviation, sigma or s. This is a measure of how much spread around the mean the data set has. The smaller the standard deviation, the closer all the x values are to the mean. So for my sample, s is equal to the square root of 15, or about 3.873. So that's how to calculate the mean and standard deviation by hand. Next time we'll take a look at where you can use this. Very, very useful. Remember, as long as you make a table, it'll keep you straight. Okay, that's all for now. Bye.